Bernd Rücker. I'm co-founder and developer advocate of Camunda. In my daily life, I basically work, or over the last 15 years, I worked with a lot of companies in the domain of workflow automation, automating core workflows basically of companies. Something like, for example, if you're an insurance company, if you want to settle a claim, if you have a new application, if you want to have a new bank account, if you mail order stuff, or if you want to have a new DSL line at home, all these kind of things are workflows we helped a lot of customer implementing. I wrote that lovely book, the BPMN book. It's available in English as well. We sell a lot of copies worldwide, so it seems to be quite good. I'm from Berlin, and we most probably will run very short in time at the end. So if you have any questions, feel free to send me an email or to tweet me. I also will be around for the next 2 or 3 hours here at the conference, so just approach me in case you have any questions. To dive into the topic of today, I want to use an example of probably a very simplified order fulfillment process, but that's very much motivated by one of our customers, which is Zalando, also active here, probably know that, where you can order clothes. And they spoke at a meetup last year in Berlin where they talked about how they implemented their order fulfillment process. So a lot of the things you see here are kind of comparable to what they did as well. I cannot disclose what they really did, but it's kind of comparable. So you can keep that in mind. But for the sake of simplicity, what I do today is I use a very simplified order fulfillment. And I use the example of the dash button. You probably know Amazon dash button, yeah? So you can just click on it and then something gets sent to you. For me, I just got my third daughter, so diapers would be the perfect use case. Diapers are getting empty, you push the button, you get a box of diapers. And in the background, you have an order fulfillment process. So obviously, you have to pay for the stuff. It has to be fetched from the warehouse, has to be put in a parcel and sent to you. So this is basically what we want to implement. And if you look at it from a perspective, there are multiple perspectives you can look at that. You probably have heard of DDD. Who has heard of DDD? Domain-driven design, or basically all of you. So you're probably familiar with these context-bounded contexts. You could make these domains, these contexts, like checkout, communicating with the button, payment, doing the payment, inventory, fetching the stuff, and shipment, shipping the stuff. So that could be it. If you're implementing a microservice architecture, it might be that these are also kind of your microservices. It's probably, who is doing microservices? Oh, a lot of you, awesome. Who is doing SOA and things that are microservices too? A couple of you. Okay, that's more or less the rest. So we can talk about microservices. So we could think about that as a couple of microservices. What's the value proposition with microservices, or what do we do with microservices? Typically, we say, okay, we have for every of these services, we have dedicated processes, so dedicated applications. So one might be a Java program, the other one might be a Go program or whatever. You have dedicated databases, local, so no shared database. And the most important thing, you have different teams caring about the services, and these teams should be able to work as independent as possible. So this is not what I want to talk about today, but it's kind of this setting the scene, okay? So this is what you probably will do with microservices. Then what I want to do today is actually to look into a couple of conceptions we see a lot when people start doing these microservice projects. And one of them is there's currently quite a hype around event-driven architectures. And there's this belief in it that events decrease coupling. And I want to quickly look at that from an example. So let's assume, it's kind of probably a silly requirement in this case, but let's assume that the button should blink if the goods can be sent within 24 hours. So that means they are on stock, right? Then you can send it directly. How could we implement that? I mean, the checkout component has the ability to make the button blink, but it doesn't know about stock. So the naive approach typically is that you ask for it, right? So inventory knows what is on stock. So you could say, okay, the checkout has to ask for inventory. Hey, do you have these diapers on stock? Yes. Okay, then we can send them in 24 hours. That would be the naive approach. What actually most people do out there, as far as I know, at least from the project. So, and basically, and it doesn't matter if this is a REST call or is it messaging. it doesn't matter, it's request response because you wait for the response before you can make the button blink. So that's kind of a coupling. If the inventory is not there, you cannot answer that question. Yeah, might be REST or messaging. What you can do now, and that's what you can do with the event-driven architecture, and that's one of the big differences. Who's doing event-driven architectures already? That's much less people here, okay? So if you want to go event-driven, that would mean you lay out the whole architecture a bit differently, and that in this case, it could mean that whenever the inventory changes something, like I have new goods on stock or I shipped something, you send out an event to the world. You have no idea who is interested in that, but checkout could say, hey, I'm interested in that, because then I can build my own database, my copy of the amount on stock locally. And as soon as you do that, you can answer the question right away within checkout. So you don't have to ask for inventory. So that reduces at least that temporal coupling thing. And inventory probably doesn't know that there is a checkout interested in the amount on stock. And other components might do that as well. So that's basically a great power of event-driven things. If you send events, they are immutable. That's something that happened in the past and something you normally broadcast to the world, these kind of domain events. That's a very important concept actually also in DDD. So that's interesting to look at. And I think it's really a powerful concept. So I think it makes sense to have a look at that. But what I see in a lot of projects, and that was happening over the last 2 or 3 years, when they start to apply event-driven, and that's the old hammer and nail thing, they start to use that for a lot of use cases, for a lot of problems. They try solving that with event-driven things. And one example of that is if you're, for example, now want to implement that whole order fulfillment flow, like you press the button and you get the parcel at home. That involves like a sequence of steps. And this you can implement with events. Something like checkout says, okay, there was an order placed. Payment says, oh, I'm interested in that because when an order was placed, I want to get the payment. And then I say, okay, payment was received. And inventory knows, oh, payment received. Then I have to do something and fetch the goods and raise an event. And the next guy in the row can take off. So this is a way how you can implement these kind of end-to-end business capabilities. And this is actually what's happening a lot out there as soon as you go event-driven. And bear with me. And as soon as you start having these peer-to-peer event chains, that's kind of a very slippery ground, because what you can easily see is that you lose sight of that flow. So it's hard to see how the end-to-end process really flows through the system. And that's what we already saw at a couple of customers, that they had a couple of hundreds of these kind of services, and they said something like, okay, it's happening, but we have no idea why and how exactly and where to change that flow. So that's pretty hard. I was very happy when last year Martin Fowler wrote a blog post. I have the link in there. And he said something like, the danger is that it's very easy to make nicely decoupled systems, so it's a good thing, but without realizing that you're losing sight of that larger scale flow, and thus set yourself for trouble in future years. And that's a very good summary of the problem you might get if you have these peer-to-peer event flows. And that's why, I mean, event-driven is very good for some use cases, but for some, it might be not so good. I can make a second example, which makes that very, very transparent, very visible. If you want to change the order of steps, the sequence, like in this case, probably we want to fetch the items before we do the payment, because we want to say something like we want to reserve the goods as soon as possible to be able to ship. That could be a use case. If you just want to change that sequence, we get a lot of trouble on the event-driven side, because that means, I like that effect actually, you see that you have to adjust 3 services in order to make that change. So if you have this event-driven mechanism here, you have to adjust 3 services to make a rather simple change in the sequence. And you could imagine more requirements coming in, changing this kind of flow. And that's why I think that's a very bad idea. And I love actually this picture, and I learned the metaphor from Eric Evans, the guy who wrote the DDD book. That's a 3-legged race. So if you look at it, you can see that always two guys are bound together by their feet, and then they start running. And what you can easily see from the picture is that everybody has to run a bit slower, right? Because you can run faster if you are not bound with another guy where you have to sync somehow the food. And the risk of falling down is much higher with these three-legged races. And that's exactly what microservices try to reduce. They try to reduce three-legged races in the company. This is a three-legged race. If you want to roll out this change, you have to change 3 services at the same time. You have to deploy them at the same time. You have to sync the teams to deploy them at the same time. Because if you don't do that, you probably end up with a chaotic thing where you say, okay, I either have unpaid orders or the other way around or whatever. So that gets a three-legged race very easy. And that's exactly what we try to avoid with microservices. That's a thing to keep in mind. It's actually not that hard to resolve that situation. So what we typically do there is we extract that end-to-end capability, like fulfilling the order, which is, that's a very important capability of like a company like Zalando. That's what they do, to extract that into a separate service, doing that. And then you probably still have some event-driven parts, probably still makes sense. Something like checkout says, hey, order placed, but then the order service can listen to that, and then we're sending commands over the wire. That's, again, it could be HTTP, it could be messaging, that doesn't matter, but the idea is the coupling is the other way around. Not payment listens to order placed anymore, but order knows, hey, I have to retrieve payment first. If that happened, I have to send a command to inventory, and so on and so on. So you extract that end-to-end capability into a separate service. That's actually a very natural idea, but a lot of people reject it in a way as soon as they go into the microservice and especially as event-driven architectures. As soon as normally when I say commanding, sending command and having an order service commanding other services around, there's somebody in the room shouting something like, oh, this is orchestration, orchestration is evil. We all learned that in order to have decoupled system, it must be choreography, it must be these event-driven things we just saw. Orchestration is pretty evil. And this conception basically roots in that, let's say, in the ancient times, like 10 years ago or 5 years ago, where we had ESBs and service-driven architectures, where you have these ESB products typically, and then you could do orchestration logic in the middleware, like in the ESB. A lot of these ESB tools had capabilities in order to wire together services in a sequence. And that was basically business logic dragged into the middleware. That was a pretty bad idea. That was a three-legged race again. Because now if you want to change anything, what normally happened is that you had to deploy the service and something in the ESB. That means two deployments in sync. Normally another team was responsible to maintain the ESB, so you had to sync there again. So that didn't really work out, and that's why people normally pick up the idea, okay, don't do orchestration. But this is not what I had on the slide. What I do on the slide is actually pretty different, and that is very much in sync to something else Martin Fowler said, which is very famous nowadays. Do smart endpoints and dumb pipes. No magic middleware, no ESB. That was like smart middleware. We want to have smart pipes, like messaging, RabbitMQ, Kafka, or whatever it is. And then we have smart endpoints. So the logic is in the services, but I had the logic in the services. That's an important difference. So you want to have that orchestration logic not in the ESB, not somewhere hidden in the middleware, but you want to have it as a separate microservice, as a separate business service here. So that's the first important thought, and I come back to that in a minute. As soon as you discuss into that direction, normally somebody else comes around the corner and says, okay, but I read Sam Newman's book. Who read Sam Newman's book? Okay, that's not that much, but normally a lot of people read it. It's a good book, I can recommend it. So he written that microservices book in O'Reilly. And there's a quote, that's from the book actually, and he said, there's the danger, as soon as you have these order services, there's the danger that these smart God services start to tell anemic CRUD services what to do. So he says, okay, that's the danger. You have that huge order service, and the other ones are just CRUD services, read, update, delete. And that, but the important thing is, the important thought is, just because you have that orchestration service there, doesn't mean that it has to grow, that it has to get a God service. The important thought is that you get these God services if you do a design like that, only if you have bad API design. What do I mean by that? And that's actually a very important thought. So I'm an example guy, so I make an example. Let's assume you have the order service and the payment service. Very easy situation. And the order service sends the command, you remember that, retrieve payment to the payment service. Now the payment service normally or probably doesn't do the payment itself. I know companies where the payment service itself is composed of 100 services because you do very different kinds of payments. But there might be a credit card service upstream, which you want to use. And now let's assume the credit card service says something like, okay, this card is rejected. It's not valid for whatever reason. Now you have a couple of choices. The first and the most naive choice normally is, okay, the payment service sends the rejection to the order service. Makes sense, right? Okay, now do the payment. But that's not, and if you do this, and let's assume you have a new requirement in the system where you say, okay, we want to give the customer some time. If the credit card was rejected, we want to send him an email, say, hey, your card was rejected, but don't worry, you have 2 weeks of time in order to update your credit card. That's what, for example, GitHub does. If GitHub charges your credit card and cannot do it, they send you an email, give you 2 weeks. And now you have the choice where to implement this requirement. And if you start implementing that now in the orchestration part, then you start creating that huge order thing, right? But you're not forced to. You should actually implement these kind of requirements as close to the service who is really responsible for doing that. So in this case, the payment service directly should do something about it. And then after it resolved everything, it either emits a payment received or a payment failed. But that's the end result, not an intermediary like card rejected. Order shouldn't care about that. And that's what I mean by bad API design. So the API to payment should be very clear. Retrieve payment, result is either received or failed. That's it. And then you get very good services. Then you don't get these kind of God services. There is one glitch or one catch, basically. If you want to do that, that means I just talked about something like I give the customer 2 weeks of time in order to update credit card details. That means I have to wait for some time. It gets long running. Or what I normally name potentially long running. Because in the good case, it's like milliseconds. But in the bad case, it might be 2 weeks. And this is something you have to handle, actually. And that's very often the problem why people are not moving into that direction and say, okay, now I have these state handling and payment. Oh, no, that's too complicated. Just push the rejected to the order. They should care about it. That's bad design, actually. And I want to make a second example because I like that much more from the storyline. It's very intuitive. And it's the same thing, but I want to reiterate over that because it's very important for me, actually. Who used an airplane before? Okay, yeah, most of you. So you're familiar with the process, right? You book a ticket. At some point in time, you get an email invitation for the check-in, right? Then you click on that. Then you get the check-in webpage from the airline. Then you select a seat, and you check the box, no dangerous goods. Okay, understood. Then you hit the button, check-in. And then normally on the next page, you get the boarding pass, right? Or you get an option to send you the boarding pass as an email. That's a normal thing. I did that, and it's a German screenshot, but I think you understand that. In this case, what Eurowings, my flight to London, they said, okay, we couldn't send you your boarding pass when I clicked on the button, right? How I envision that in the background is, okay, I clicked in the web UI. The web UI probably talked to a check-in service, probably via REST. Most of the people are using REST most of the time synchronously. Different story. This probably talked to other services upstream. And I think probably the barcode generator blew up. That's what I think that happened. Probably completely mistaken. But what they did is they made that my problem. Why? Why? What should I do? I mean, what should I do if the barcode cannot be, or if the boarding pass is not generated? What would you do? I cannot hear anything. So I give you the three typical answers I normally get. It's either you print the error page, which is kind of, what should I do with the error page? But probably at the airport somebody, no way. You call the airline, okay, that's fair. I escalate that. Or I retry, obviously, I'm a programmer. I do it again, try to turn it off and on again. That's what I did. And it didn't work like a minute later, it didn't work like 5 minutes later, but it did work a couple of hours later, which is very logical to me, which is, I think, very unlogical to normal people. But it was. But what they do is the same thing. They make that my problem as a client. In this case, I'm a human client. It could be another service client, but they delegate the problem far up the hierarchy. Much more components now have to take care about that. That's bad design. And in this case, I even made myself a calendar entry to not forget to check in, to print the boarding pass. The funniest part of that story was my flight back from London, or flight onwards, was EasyChat. EasyChat said, we're sorry. So I had the same problem, exactly the same problem. But they gave me actually the work instruction, which is kind of neat. Please log on again. Oh, retry. If that doesn't work, please try again in 5 minutes. Increase the interval. Okay. And the best thing is we do actively monitor our site. We'll be working to resolve the issue. There's no need to call. It's your problem. It's your problem. Don't bother us. We don't want to know about it. Your problem. So that's bad design. I mean, you should do it like, hey, we're having technical difficulties. Oh, that's bad. That's our bad. But don't worry. We will figure everything out and send you an email. I mean, it's asynchronous anyway. I get an email or an SMS. They can send them whenever they want to, just right before the flight. And that's exactly the same story like with the payment before. That's bad API design. In this case, even towards the customer. So the better thing would be to resolve it within the check-in service. So if I cannot generate the barcode, I have to retry until it works. I don't have to bother my clients with that. Thing is, again, and that reduces complexity, by the way, of the whole architecture, because it's now much more isolated, or much smaller parts of your architecture have to deal with that kind of failure. It even gets much easier in the bigger picture. But the thing is, what I said, the glitch or the catch, you have to handle state. And that's why a lot of projects don't want to go down that route. Oh, I have to. I mean, if you promise to send the boarding pass, you should do it actually, right? Would be a good idea. And that means you have to handle state, because if it takes 4 hours, you probably restart some services in the meanwhile. What's the normal way of handling state? That's actually, I mean, we are 2018, it's not hard to handle state. The normal thing is actually to do what I call a persistent thing. It's normally an entity, but it might be a document, it might be a persistent actor. I don't care about how you exactly store it, but it means you store it yourself. And kind of a object, you store it somewhere. Normally people sense that this is kind of an effort, because they now have to deal about okay, but I have to do the retrying, so I need some threading, some jobs, probably some timeouts, some timing mechanisms, so I have to do, to implement a lot of things. So that might get a lot of effort, which is normally kind of true. So especially if you have these longer running stuff, like I retry for 4 hours or 8 hours, it means that I probably have running things all the time. So if I redeploy changes, I have to take care about versioning, these kind of things. I probably want to operate that in a way that I see something, how many payments are currently pending, all these kind of things. So there are a lot of requirements you normally get around handling states. But on the other hand, I mean, there are a lot of tools available, and that's why my personal heart always bleeds about that, because I'm a workflow guy. I'm doing workflow engines for all my professional life, actually, like 15 years or 16 years. I worked on a couple of open source engines, and I mean, these are in the heart, it's a state machine. They are actually capable of doing exactly that. But normally, if you propose something like this, like a workflow engine to this use case, people are saying, oh no, workflow engine, this BPM stuff, oh no, that's so complicated. and there's proprietary, that's heavyweight, that's like vendor-driven, and as a developer, it's really hard. It's what I call death by properties panel. I have to click through a lot of these kind of panels, watching a YouTube video, where to click, and I cannot copy-paste, cannot check it in GitHub, and these kind of things. That's what you normally hear from people when they hear workflow automation or BPM or whatever you want to call it. But that's not true, and that's one of the important things I also want to get through. If we are looking at the workflow engine market in 2018, there are a lot of things happening. So if you look at the, for example, at the big cloud vendors like AWS, but also the others, every cloud vendor doing some kind of serverless is currently concerned with the problem having a lot of functionality in rather small stateless functions, and you have to combine them into bigger things which are kind of useful and very often stateful. So for example, AWS does step functions. IBM does something similar. Google just started something. So there are a lot of things which are in its heart a workflow engine. If you look at the Silicon Valley stacks like Uber, developed Cadence 2 years ago, Netflix did Conductor. They are very proprietary to their environment. So Netflix, for example, you have to use DynamoDB for persistence. Uber is going Cassandra. It's not like the everyday stack, but they recognize the problem and they build solutions for their stack. So that's very, very much out there. But there's a bunch of also open source components available, which are really interesting to look at. For the Java space especially. Who's using Java in the room? Oh, wow, that's most of it. Who's using .NET? Golang? PHP? What JavaScript? Oh, sorry. Okay, yeah, wow, pretty good mixture. Okay, I lost track, sorry. No, but for the Java space, there are a lot of them out there. They're open source. Most of them are, at least the 3 down there, are kind of comparable. CB might be interesting. That's a project from us. We're currently doing their horizontally scalable workflow engine. So there we're based on event sourcing, basically, and it's hard to reach a scalability, which is really far beyond what workflow engines of the past could do. So that probably is interesting if you're interested in that. But today I want to dive just to a couple of lines of code because I hate doing talks without code. And there I use the Camunda engine, which by coincidence is the one from the company I co-founded, so that's probably a bit biased, but the other ones are kind of comparable from the idea. And there you can do stuff very, very lightweight. So what do I mean by lightweight? And that's, I use Java code, but you can do more or less the same with .NET as well, or also with JavaScript or others. So in Java, you could do something like, okay, I create me a process engine, which is a workflow engine. That's the state machine. If I don't configure it that special, it's one line of code. Then I can define the flow, basically, what I want to do in a sequence, for example. I can do that in Java if I like. I can do that in code. Yeah? That's possible. By the way, everything you do is we auto-generate also an image out of that, or you could also start modeling graphically if you prefer that. But I prefer to start with the code, actually, because then people realize that there's nothing hidden, nothing magically hidden. If people start, most people, when they see a picture, they imagine some magic in the background, but there's no magic. It's very easy to do. So you can select if you want to do code, or we even work on a YAML format if you don't like the XML format or whatever. So it's very easy to define these kind of flows. Yeah, we are using BPMN, by the way, as most of the engines. That's an ISO standard. That's what we wrote the book on, though that's probably interesting to have a look at. And then we can attach code to these flows. So whenever we are doing that, whenever an instance passes through, the code below is executed. And then we can start instances. So that's very easy to do. It's on one slide. That's all the code you need. We need a relational database underneath, and then you're ready to go. And you get a lot of stuff out there. I only go into a couple of the things. But now you have a state machine. And that's now BPMN. Yeah, and use the graphical format because it's easier to understand, but you can do the same thing in code. I could do something like, if the credit card cannot be charged, I inform the customer, and then I wait. And then you have that small little timer waiting for 7 days. That's built in. You have the notion of time. You have it persistent. You can switch everything off. It's in the database. I mean, long running means basically waiting for a long time, not really doing something. And you can use that for much smaller use cases as well. So yeah, time. So what we have a lot, what I said earlier, most projects I now communicate via REST. Who is using REST? Synchronous calls, yeah, most of you. That's what I see most of the time. And there you can do something like retrying. If the peer is not available, I have to retry it, but probably not only like 3 times in a row, but also stateful, like an hour later, 2 hours later, 3 hours later. And again, you want to have that reliable, want to have that persistent. That's from my perspective, a very important aspect of these kind of communication architectures. If you're going asynchronous with messaging, you probably focus more on the timeout aspect. If you're doing REST, you focus more on the retry aspect. Okay, obviously, if you have these kind of retry capabilities, the service provider has to be capable of taking the retries. Idempotency. I just give you a couple of keywords here because I don't have time to dive into details. But I mean, it's obvious if you do the retries, the service provider has to be idempotent. That's something you should always keep in mind. Whenever you can make something idempotent, that's great for your microservice architecture. Because, and that's second important thought here, and what I still see a lot of people not realizing, as soon as you're saying microservices, it normally means you're running a distributed system, a highly distributed system, a complex system. Distributed systems, I like this picture from that. I stole the metaphor from Jonas Bonnet from Lightband. The network is that rough ocean. Your application, your one service is that nice little hut. Transaction management, one JVM, for example. It's really cozy in there. There you can develop like you know it. It's cool. It's fun. But whenever you open the door, there's the network. And there, bytes will be turned around, the service will not be available, probably slow is really bad, and a lot of things will happen. And you have to reflect that in your architecture. That's important, and you really have to think about that. That's nothing that can be hidden by some kind of magic infrastructure. You probably heard the issue talk. There's a lot about circuit breaking, these kind of things. That's basic infrastructure, which is very important, but on top of that, you really have to think about the problems you get out of that. One important thought, whenever, let's assume you're calling REST again. Whenever you're doing a REST call and you get a network error, you have no idea if you haven't reached the provider, if you have reached it and it blew up, or if it did everything you wanted to, but the response got lost because of a network error. You have no idea. Messaging is the same thing. You have no idea. And that's important. That's important to have in mind. So whenever, the slides are online, so don't worry. I'm a bit fast in changing slides here. So whenever you do something like this, charging the credit card with a couple of retries and say, okay, it doesn't work, and you throw an error, that's probably not enough. You probably have charged the credit card, and you don't know. You have to think about that situation, especially in payment. The customer might not be so relaxed about that. So you probably have one, probably not the only strategy, but one strategy could be to do a refund, even if it's not there. Or you do other things. The important thing is to think about these kind of strategies and, do it reliable. State machine. Last thought. Basically, within these distributed systems, and when we are talking about these kind of unreliable things, I probably charge the credit card. Normally, you start thinking about transactions. And transactions or consistency as a bigger topic is a very interesting one in distributed systems. And a lot of people still try to approach that from an infrastructure perspective. For example, with two-phase commit XR transactions. There's a great paper. It's still very, very, very up to date from Per Talent. At that time, he was at Amazon. Currently, he's at Salesforce. He wrote about life beyond distributed transactions, and he really did a good job describing why these kind of transactions don't scale, at least not in 2018. So you should not use distributed transactions at all. Don't rely on that. You don't have it in distributed systems. But you have the requirement. You have the requirement of doing 3 things in a row, and if the third one fails, you probably have to roll back the others. What do you do? Typically, what you do in distributed systems is you use a different strategy, which is called, in BPMN, it's called compensation. You probably heard of the Saga pattern. That's also very well known, which is kind of, I do that transaction, on a higher level. So I say, okay, I do that first. Then if I fail later on, let's see if I get this to work. Yeah, if I fail later on, this one triggers the compensation, and that means all activities which were executed successfully in the past and have a configured compensation activity, then this one is automatically triggered. And that's what the workflow engine can do for you automatically in the background. And again, right, reliable. So if you're talking REST again, the restore customer credit might not be available at the moment you want to restore, so you do retry again. So these kind of things you have to think about. So yeah, we skip that. So you have that timeout stuff, you have the retry stuff and the compensation stuff, very easy to think about. And one important thought for all your services you provide, you not only have to care about idempotency, you should also care or think about offering compensation activities. Most projects I know suffer from not having these available. You can, whatever, create an invoice, but you cannot void it, for example. You need these kind of services. That's very important in microservice architectures. Okay, last thought, just to make that very tangible again. So I spoke about having the order service, the orchestration part, as separate microservices. So that means, from my point of view, I don't see that workflow engine as a separate component drawn as a separate box, but I see it as implementation detail of one service. So if I have multiple services doing or requiring these state machines, they just embed that and run that, and then they have these long-running capabilities under the hood. Okay, so this is how I envision it there. Okay. If you're interested in more details of that, but that's a quote what we hear from a lot of projects out there. I like that quote actually because it summarizes it very good. It's from 24 Hour Fitness. That's one of the biggest gym companies in the US. You probably know gyms, I hope. Before mapping process explicitly, the truth was buried in the code. And that's what we see a lot with these event-driven stuff, but also with messaging, retrying. A lot of things are really buried. So that's quite valuable. And if you're interested in details, I skipped that for today's talk because I run out of time. But I wrote a blog post how you can really run this kind of workflow engine in different architectures, because that's important. Like if you're in .NET, if you're in Java, there are a couple of options. I don't go through them. All are in the article, like with Spring Boot or Wildfly or WebSphere or C# or Golang or whatever. There are a couple of them. Just go into the blog post then. If we do a reality check, that's, I mean, what I said, a lot of the slides are not disclosed, but this one they showed. It's a very simplified version of what Zalando does there. But what you can see there is already that they're sending messages, they're waiting for messages. They're using, by the way, Kafka underneath. So that's very comparable to what I had on the slide. So that's kind of really realistic, even in big scenarios, what you can do there. Yeah, and Zalando is pretty big. They are doing a lot. Awesome. If you're interested in more code, you can either approach me afterwards. I can show you everything as a demo as well, dive into all the codes. There's a GitHub repo. There I have all the services I shown today. I have it in Java and .NET, C#. Using Kafka underneath for event-driven part, and parts of it I also have as a direct REST call, so you can see everything I've shown today also in much more concrete details in code, which is very often very helpful. So that's probably a resource to go to. Wrap up, last minute. I should be fine on time. So I think event-driven is great. So that's a good thing to have that in mind. I know that most people are still using REST. That's also fine. I mean, you can even do event-driven thinking with REST, but probably messaging is a good idea as well. But keep in mind that there are limitations of that event-driven. So if you have these kind of complex chains, peer-to-peer things, think about orchestration. Orchestration don't have to be something like central. So it's use something embedded. You probably have to want to code it yourself, but if it's stateful, probably workflow engine can help. So that's the quick summary. Thank you very much. I hope that was kind of enjoyable. this is a slide which might make the most sense to make the photo of. So there are all the links, again, to the GitHub repo, to me, to the articles. I wrote an article on InfoWorld or InfoQ, which are kind of comparable to the stuff I talked about today. And if you have any questions, approach me later, send me an email, send me a tweet. Thank you for coming, and enjoy the rest of the conference. Thank you.